everyone. If 1200 centimeters squared of material is available to make a box with a square base and an open top, we're going to find the largest possible volume of the box. So I kind of made a box here. Remember, it's open. So let's let the base of the box be B. This be the height. So we do have a bottom here to the box, but not open. So basically, if we do the surface area, we only have this bottom of the box, which is base squared. So the surface area equals base squared. And then the area of each of these sides is going to be base times height. And we have 4 sides, so it's going to be 4 HB. Now our surface area is given at 1200. So you have 1200 equals base squared plus 4 HB. Now let's solve for H so we can do our first derivative test to find the maximum possible volume. So we're looking at this one to do the absolute extreme values. Now to solve for H, we're just going to do H equals, to write 1200 minus your B squared and then divide by 4B. So now that we have H, we can use our volume formula, and our volume formula is going to be B squared times H. So you're doing each of the sides like that. All right. So now that we have that, we're going to substitute, and we're going to get this equals B squared times H, and this is your H. So that's going to be 1200 minus B squared divided by 4B. All right. So basically, if you simplify this, let's see, you can distribute here and divide. We can divide by B on each of these pieces. So this is going to be 1200 B squared minus B to the 4th, and divide each of these pieces by 4B, and that's going to give us 300 B minus B cubed divided by 4. So that's going to be your volume now, just simplified. All right, let's write that over here. So we have our volume of B equals 300 B minus B cubed divided by 4. Now, we're going to use the first derivative test for absolute value, or absolute extreme values. So let's take the derivative of this, of our B, and we get 300 minus 3/4 B squared. You set this to 0, and you're going to get 300 equals 3/4 B squared, and that's going to give you B, if you multiply both sides by 4/3, you're going to get B, and then square root it. You're going to get B equals square root of 400. And remember, it has to be positive. Okay, because we're talking about positive. So basically, we'd have 400 equals B squared. Therefore, B equals square root of 400. Now, let's look at our test here that we're doing. So basically, if the derivative of B, the volume of B, is positive for 0, this interval here. Now, so it's positive for this interval, and for when it's negative, that's going to be when b is greater than 20. And all I did was plug in a number in between. So plug in 10 here into this. V prime of 10 is going to give you a positive. And if you plug in, say, 30, so V prime of 30 is going to be a negative number. So that does follow our A guidelines. If the derivative is positive and then our x is less than our critical number, which is our critical number, then and then also if our derivative is negative and our x is positive than our critical number, like we had here, because this equals 200, this equals 20 there. All right, then it is the absolute maximum. So we'll plug that in, and you're going to get b equals 20. So therefore, let's plug in our h equals 1200 minus, and we're going to put 20 squared, that's your b, divided by 4b. So that's going to be 4 times 20. And this equals 10. So the largest possible volume, b squared times h is your volume, equals 20 squared times 10, which equals 4,000 centimeters cubed. And that's your final answer. Thank you. Have a nice day. Bye-bye.